Good morning to one and all present here. In this video, we are going to see about the error control and flow control mechanism in computer network concepts. In this video, we are seeing about the data link player control, flow control, and error control concepts. In a flow control, we have to ensure the sending entity does not overwhelm the receiving entity. It has to influenced by the transmission time, propagation time. It has to there is no burst time and there is no varying delays. Both sender and receiver having the same transmission time. It has to made from the transmission, so it will be having with the frame one having with the two destination in a frame one. It will be having transmitted with the frame by frame. So with this, we are seeing about the flow. First thing is an flow control. First, we are seeing about the stop and wait flow control. So it has to source transmit into frame. So it has to receive the frame and reply with the acknowledgement. Source waits for acknowledgement before sending next frame to the destination. It has to work well for an large frame. Stop and wait become inadequate in a large number of data split into smaller frames. This is sample format from and transmitting the data. So while we are transmitting A and B, we have to utilization of our stop and wait protocol. Next protocol is a sliding window protocol. So it will allow the multiple number of frames to transmitting the data. So receiver having a buffer. While we are buffer is an overflow, it indicated that it is overflow. Otherwise, it will transmitting. Buffer has to be in both the sender and receiver side having a buffer. So in this acknowledgement has including the next frame number and also sequence number. So receiver can having acknowledgement frame without permitting further transmission. It has to must send a normal acknowledge to resume if you have full duplex link and have a piggyback acknowledgement. This is a sliding window diagram. So we have to transmitting the zeros 0 to 7. So initially it has to block with the 0 to 4 and then we have to remaining 3 will be transmitted. So this is sample diagram for transmitting the data for and receiving the acknowledgements. This is another example for sliding window example. Next, we are seeing about the error control. With this, we are seeing about the error detection and error correction techniques. We have to in computer networks there are two types of errors has to be occur. One is an loss of frame, another one is an damaged frame. So in this, we have to using the common error control techniques. We have to using identify the process with this. First one is an error detection, and then we having a positive acknowledgement, and then retransmissive, and then read negative acknowledgement and retransmission. This main we are using the ARQ protocols with this collective name of such as error control mechanism. Most error control mechanisms are an error reduction scheme, retransmission scheme, and then error control. We are using the ARQ. With this ARQ, we have three types of an protocol, such as an stop and wait, go back and ARQ, selective repeat ARQ, stop and wait ARQ. So with this, source transmit single frame to destination and wait for an acknowledgement. If it is received, frame is damaged, discard it, and no acknowledgement transmitter. Wait till the timeout. If no acknowledgement within the timeout, it has to retransmit. If acknowledgement is damaged, so transmitter will recognize and retransmitting the data. Stop and wait ARQ, it has to avoid the frames and then alternatively labeled with the zeros or one in a frames. Acknowledgement 0 and acknowledgement 1, and then in a sequence number is in 0 or and 1. This is a sample format for a stop and wait protocol. Next thing is an go back and ARQ protocol. So it is a continuous ARQ based on that sliding window. If it is no error, the operations are identical to sliding window. It has used to control the number of outstanding frames. So when we are saying it is reject I, if we are having a error, after that the receiver discard all incoming frame until the frame in error was correctly retransmitted. If sender received a reject I, it will retransmitting the frame I and all the packet I plus 1 to I plus n which has sent but not an acknowledged. In go back NARQ damaged frame, has to be an invalid. It has to discard the frame and then remaining has to be an forwarded. Go back NARQ damaged request received. It has two subcases. Receiver gets frame and transmitter timeout. And then damaged rejection. So it has to damaged frame and has to handle for the last of the frame. Next thing is an selective reject ARQ. So it has also called it as a selective retransmission. So it has to only rejected transmission frame only retransmitted. Subsequent frames are accepted by the receiver and buffered. So it will minimize the transmission time. Receiver must maintain a large enough buffer. It has to more number of logic transfer. Hence, it has to widely used. It will be mainly used for a satellite link and long propagation delays. This is sample for an go back and versus selective reject. Next thing is an high level data link control. It is an important data link control and it will be specified as an ISO 33009, ISO 4335. It has a three station type: primary, secondary, and combined, and then two kind of link configuration: unbalanced and then balanced. Next thing is an transfer mode. So it has to three types of transfer mode: normal response mode, it has to be an unbalanced configuration, and then asynchronous balanced mode, it has to be a balanced configuration mode. Next thing is an asynchronous response mode. This is also unbalanced configuration. Secondary may be initiate transmit without permission from primary. It has to rarely used. HDLC frame structure. So it will be having a bitwise operations. The first one is an flag, next thing is an address, next thing is an control, and then information, flag frame check sequence, and then flag. HDFC LC frame structure. It will be having a bit 0, 7 1 and 0. So 0 will be inserted for every sequence of 5 ones. If a receiver detected 5 1, it checks next bit. If next bit is 0, it is detected. Otherwise, it will be having a errors. It will be having identify secondary station that will send will receive the frame, usually 8-bit long frame formation. Maybe it has extended multiple of 7 bit. It has to several frame types. It has to transmitted. NS means data sender. NR means data receiver. This is a frame structure for an our HDLC formation. While we are using the frame check sequence, it is used for error reduction. So it will be using a 16-bit CRC or an 32-bit CRC checker. So this is a sample for an HDLC operations sample. That's all about the HDLC operations and data link control and error control operations. Thank you.